Let's look at another example of some another site that's offering MP3 downloads, and kind of compare it to the first one. Keeping in mind, we're not thinking of it in terms of slope and y-intercept, but initial value and rate of change. So it says another site is offering MP3 downloads with a different price structure, a $2 monthly fixed fee plus a fee of $40. I'm sorry, not $40. Woo, 40 cents per song. There's that word per again. So we're going to write a linear function that models this relationship. As before, let X represent the number of download songs and Y represent the total monthly cost. Okay, so I'm going to show you a couple different ways here. You could write it as Y equals, now, our slope. Our slope is our rate of change. It's the number we're multiplying by. So right here, we're going 40 cents per song. That's what we're multiplying by. Okay, so I'm going to go 0.40 times X, the number of songs. And then we have a $2 fixed fee. That's our initial value. We're paying $2 even if we download 0 songs, and that's what we add on. Okay. Remember though, kind of our new structure that you could start seeing these things written as is Y equals, you can put the initial value first, 2 plus, but notice I'm not multiplying by 2. Even if I list it to the 2 first, I'm still adding my rate of change on. And I kind of like this way better because it follows the order I'm going to do when I graph. I'm going to plot my y-intercept first. Okay, so determine the cost of downloading 0 songs and 10 songs. Okay, 0 songs. X represents the number of songs. So I am going to say X equals 0. And then I'm just going to input it into one of my equations here. Right here. Y equals, and again, it doesn't matter which one. We're just changing around the plus sign. That's community property. Times 0, because I'm inputting 0 in for X, plus 2. And, well, 40 cents times 0 is 0. 0 plus 2 is 2. So Y equals 2, or $2. Okay? Now I'm going to put in Y equals 10. I'm sorry, X equals 10. X represents the number of songs. Okay? So I'm going to go Y equals our 40 cents times 10, because I'm inputting a 10 for X. X represents the number of songs. And then you would type this into a calculator and you would get $6. Okay? So the graph below shows the linear model for the first subscription. Okay, so this is company 1. This is the one we did previously, the 0.25x plus 3. Now it says graph the equation line for the second subscription site, this one up here, by marking the 2 points from your work in exercise 2. All right, what we could do is rise or run, right? I could start at 2, and then I could go up 40 cents and over 1, because that's my slope. It's a little tricky though. You could still do it. You just gotta be careful if you're going up 40 cents. You know, you just gotta be careful going up. Go up 40 cents over 1, then I'm going up another 40, so I'm at 80 cents, go over 1. It's a little trickier. But if we mark the 2 points, remember we just need 2 points to our line, look here. If my X value is 0, my Y value is 2. Well, that's my y-intercept. If my X value is 10, my Y value is 6. So I can go 10, 6. And then grab a line. And hopefully my line's kind of thick, but we can make it work. Okay. So now we can compare these two. This is company 2 down here. Okay, company number 2. So then let's answer some questions about it. Which line has the steeper slope? Well, the steeper slope, remember that's the one that's increasing faster, right? That's going to be company 2. Company number 2. Which company's model has the more expensive cost per song? Okay, well, notice company 2 is paying 40 cents per song, where company 1 is paying 25 cents per song. So that steeper slope means or steeper slope or rate of change means it's more expensive per song, which we saw 40 cents is bigger than 25 cents. Okay, so the rate of change is greater, the slope is greater. Which function has a greater initial value? Well, that's going to be company 1. Okay, company 1. Just starts right here at 3, and this one starts at 2. So, which subscription site would you choose if you only want to download 5 songs per month? Well, if I look at 5 right here, which one would I rather pay? And you know what? I hit company 2 first. So company 2 is below company 1, which means it's cheaper. Okay? So if I'm downloading 5 songs, I want company 2. But what if I want to download 10 songs? All right, so if we look here at 10, notice if I follow my lineup, I'm going to hit the black line here, company 1. All right, and my explanation for both of these, real quick, cheaper. Okay, I want to pay less. All right, so that's kind of cool how we can see the visual of it on the graph though. Okay, at some point it switches, and maybe we'll have to say, hey, I'm planning on downloading this many songs, so that's a company I want to go with. All right, let's look at one more quick example. Again, I'm hoping you guys seeing this isn't brand new information. It's just how we're thinking of our information that's a little bit different. All right, so when someone purchases a new car and begins to drive it, as they say, as soon as you drive it off the lot, the resale value goes down every single year. So we're going to let X represent the number of years since purchase and Y represent the resale value. The linear function that models the resale value based on the number of years is Y equals 20,000 minus 12,000 times X. I am going to change it to plus a negative 12,000 times X. Remember, subtracting is the same thing as adding the opposite. Keep, change, change. Now, the reason I do that is because this direction right here, these directions right here say identify and interpret the rate of change. Well, the rate of change is the number attached to the X, the number we're multiplying by. So it's a negative 1,200. You don't have to change it to a negative, but you have to recognize that there's this negative right here. That minus becomes a negative. Okay? And if we're interpreting that, well, the car is decreasing, right? It's decreasing $1,200 per month, right? Because we're multiplying. I think we're by month here, right? Oh, no, per year. Sorry. Hopefully I caught you before you wrote that down. Number of years. It's decreasing. The value of our car is decreasing $1,200 per year because it's a negative 1,200. It's going down 1,200. Now, if we have to identify and interpret the initial value, that's the number that's being added on, no X there, and that is $20,000 or 20,000. Okay, what is that? It's what we purchased the card for. What we purchased, or what you purchased, whatever. We purchased the car for, or what's original value, or something like that. Okay. So, is the resale value increasing or decreasing? Well, I kind of already answered that, right? We're going to say it's decreasing. The rate of change is negative. That's why that changing to addition helps. So the value of the car is going down. All right, so interpreting, remember this whole lesson's on interpreting rate of change and initial value. Well, remember, we can use a slope-intercept form, okay, to write equations. But instead of thinking of it as slope and y-intercept, we're going to think of it as rate of change and initial value. If our rate of change is positive, the function is increasing. If it's negative, the function is decreasing.